Okay, so we are back with our Java, the complete reference guide videos. I apologize about the fan I have running here. Let me just, 1 second, I gotta pause this. Okay, this is better. Okay, so we are on chapter 3, I think, and we're reading about the floating point numbers. Again, after I finished my certification in Java, I felt very familiar, and I coded a couple of programs, right? But I find that this book, the complete reference guide to Java, actually gives you pointers that you do not learn about in school. This book is so thorough, it's amazing. So I have it also on screen, digital copy, and so we're going to read through it as basically as if we was learning Java from the beginning. And I decided to do this also because the book uses the command prompts, um, basically the terminal, the command line terminal for the for writing programs and such, and I've never done it, so I've learned a lot in the last 2 days going over reviewing the first chapter. So let's get going. Let me get off the screen, and here we go. So floating point numbers, also known as real numbers, are used when evaluating expressions that require fractional precision. For example, calculations such as square root or transcendentals such as sine and cosine result in a value whose precision requires floating point type. I'm having a little bit of trouble with my microphone. Okay, give me a second. Okay, hold on. Hello, hello. Okay. All right. I think we're good now. All right. Java implements the standard IEE 754 set of floating point types and operators. There are two kinds of floating point types, floats and double, which represent single and double position numbers, respectively. Their width and ranges are shown here. Um, 64 bits is a double and 32 bits is a float. Each of these floating point types is examined next. Okay, so let's start with the float. The float specifies a single precision value that uses 32 bits of storage. Single precision is faster in some processors and take half as much space as double precision, but will become imprecise when the values are either very large or very small. It's interesting to know. Variables of type float are useful when you need a fractional component but don't require a large degree of precision. For example, float can be useful when representing dollars and cents. Here's an example variable declarations. Float, high temp, low temp. Double. Double precision, as denoted by the double keyword, uses 64 bits to store a value. Double precision is actually faster than single precision on some modern processors that have been optimized for high-speed mathematical calculations. All transcendental math functions, such as sine, cosine, square root, return double values. When you need to maintain accuracy over many iterative calculations or are manipulating large valued numbers, double is the best choice. Here's a short program that uses double variables to compute the area of a circle. And of course, we're going to write this in the terminal, which again I'm learning how to use. So this is pretty cool. It's going to be great. And let me move the terminal to the screen here. And let's get started. So first, what do we call it here? Oh, area. Java compute the area. The cool thing about writing in the terminal is that you have to be extra careful than if you were writing on a regular IDE, because the terminal is not going to correct your mistakes. Okay, static void main. So you have to pay really close attention to everything that you're typing here to avoid mistakes. Let's see. Double pi r a. All right, let's see the rest of this. Okay, so I'm just going to write it on the same line. I'm just going to declare it right here. Pi 3.1416. Okay. And then, oh, excuse me. R equals 10.8. And then A equals, okay, pi r r, and way close. Okay, with semicolon. By the way, the reason why you see the letters changing color is because the letters are actually transparent and they take the color of the background, whatever they are. So it's a really neat thing. And this is a regular terminal format. Alright, that being said, let's go into the next line. System.out.println. Let's type it here. Area of circle is A and semicolon. Okay, I think I did everything good. Okay. Alright, so now we need one more semicolon and we're good to go. Brace, and one more brace. Okay, so now to save this, we press Control O, Enter, Control X, and then we compile aria.java. If there are no mistakes, it should just compile. And it looks like it did. And then you can see it right on the bottom. Okay. And now Java. Oh, made a mistake there. Java. Oh, yeah. And there it is. Let me clear this and then just run it again. There we go. Could not find our little main class area. Oh, that's funny. Yeah. As far as I know, you don't need. I don't remember that you need to do this, but let me do it. No. Okay. So aria.java class. Oh, here's a mistake. Oh my god. Aria. Okay. You see? So you gotta pay attention. So now we compile again. Aria.class. Invert flag. I mean, oh my god. Oh, I'm being stupid. Ah. Anyway, okay. Java dot area dot Java. There is compiling correctly. Okay, there we go. And now, let's remove. Let's remove r dot Java in. I think is capital Java in r dot class. Let's remove those. Okay. Let's see. Okay. Okay, so now let's make sure that we don't have R. There we go. Okay, and now let's Java area. I think we could just do that. There we go. Area of circle. Here it is. Okay, let's make the one a little smaller. And there it is. Let's see, how can I view the font of this window a little larger? I wonder. Font size. Just making. Font. Okay. Alright, so there. Font is a little larger like that. Okay, good. Now let me just. Alright. Okay, so now. Let's. Here we go. Area of a circle is 366.436.224. You know what? Let's change something. That Java. Let's change something. Let's introduce another line, and also let's do it here. I need to do this. And we need to compile again. Java. One error. Where is the error? Oh. It's too bad that I cannot just like. That was the error. Okay, now we compile again. There we go, successful. And now we run it. There you go. Area circle is 366. The spaces. Okay, good. So now let's keep reading. Characters. So let's remove me. Oh, let me leave it there. Okay, so Here we go. Okay. In Java, the data type used to store characters is char or char. A key point to understand is that Java uses Unicode to represent characters. Unicode defines a fully international character set that can represent all of the characters found in all human languages. It is a unification of dozens of character sets such as Latin, Greek, Arabic, Cyrillic, Hebrew, Katakana, Hangul, and many more. At the time of Java's creation, Unicode requires 16 bits. Thus, in Java, character is a 16-bit type. The range of a char is, or char, let's just call it char, is 0 to 65,535. There are no negative chars. The standard set of characters known as ASCII still ranges from 0 to 127 as always. As the extended 8-bit character set, ISO Latin 1 ranges from 0 to 255. Since Java is designed to allow programs to be written for worldwide use, it makes sense that it will use Unicode to represent characters. Of course, the use of Unicode is somewhat inefficient for languages such as English, German, Spanish, or French, whose characters can easily be contained within 8 bits. But such is the price that must be paid for global portability. Okay, and there's a page there, unicode.org. Let's open it. And we can read that later. That could be useful. Alright, so here's a program that demonstrates char variables. Okay, so now we're going to write another program. And so what I want to do is, okay, I want to stay here. Okay. And I want this to stay visible no matter what I'm doing. So this way everything that I create will populate here. Okay. There we go. Alright. I wish I could make that bigger. Let me see. Oh yeah. Holy crap, I didn't know I could do that. Oh my god, Apple is amazing. That is crazy. I did not know that I could do this. Wow. Well, there it is. Okay, so I think that down here. Okay. Okay, that's better. I think we see everything. Okay, so let's create this program. Okay, we're gonna open it. Let's clear this. Okay, clear. Here we go. Now we're going to type in nano, and we're gonna name chart demo.java. And you know what? I'm just going to change the settings of this right here for the text, and I'm going to take away its opacity so that the text can always be read. Alright, that's what's gonna happen. And it actually might be easier to read white text. Yeah, somehow I feel like it's brighter. Alright, let me see. Yeah, that's much better. Okay. Alright. So, oh, I shouldn't have the mouse visible. And I pause the video and I'll be right back. Okay, so now we are back. Okay, alright. I had to look up how to hide the mouse, I don't remember. Anyway, what are we looking for? This. Oh, and also iTerm 2. So I'm thinking of using iTerm 2 instead of the other one, only because I think I'm going to clear scroll back history. Allow this in the future. Okay. Okay. Okay, so we're gonna do terminal job. Okay, so I'm gonna use this one actually. I'm gonna close the terminal. Well, at least I'm gonna leave it lying down here because I think that this one is actually nicer. Um, and this is, I can keep track of time because it tells me the time right on the side here. So I'm just going to make the text a little larger. Make text bigger. Here we go. Okay, so alright, yeah. Okay, so again, let's clear it. Okay, and what is this? I don't know what that is. Okay, so let's make sure. No. Okay. Current directory. Okay. And oh, it doesn't give me a list. Oh, that is funny. Well. Okay. Well. Okay. So now we're talking. All right. So let's clear that again, and we're going to hide this for now, and we're going to develop this code that is in the program. So we're going to open Nano, and we're going to call this car demo. Oh, I think we already. Wait, hold on a second. I think we already did this. Isn't car demo here? Oh no, we didn't. Okay. Nano car char demo .java. Okay, so demonstrate char data type class char demo. Okay, let me just do this right now. Okay, public static void main string gs arguments, and then oops. Alright, and now let's okay, so char ch1 equals what? 80a, and ch2 equals y. Okay, I think that's it. Okay. Alright, and oh, a message here. ch1 for X. Alright, and then system that out that print. And let me just copy this. I think I forgot how we do this. Control 6. Okay. And okay. And let me see if I can. Okay. It didn't work. Oops. Live and learn. So we have to delete all this manually. I know there is a way to print copy this, so print and then okay. Was it G? Mm, okay. A character and forward, backward, previous line. Oh, look at that. Went to the beginning of the current line. Went to the end of the current line. Forward page, backward page of text. Refresh, display help text. Refresh display. Delete the character at the cursor position. Mark cursor position at the beginning of selected. This is mark when already set. Alright, actually I need to move this a little to the left so we can read the whole thing. Okay, so what was that? Okay. What's just happening here? Okay, so here we go. Okay, so we're gonna select the text. No, setting mark when already set on select text. Cut selected text displayed in inverse characters. The selected text boundary in the cursor side ends at the left edge of the cursor. So we selected text to the left of the cursor, the character, so it's not selected. Okay. So on cut paste, let's cut text inserting it at the current cursor. Insert a tab at the current cursor position. Paragraph. To invoke the spelling checker, working position. Oh, so there is no like coping. You actually have to cut and like you actually have to like cut and paste again. Okay, so then it would be K, I believe. Okay, and then to uncut would be to copy. Okay, so now we know what to do. All right, so as far as the code is concerned, now we can move a little to the right. Okay, move the book down a little bit. Okay, and this will help. So we'll get to the right. Okay. All right, so and CH1 and CH2. Okay. And then I will uncut again. Oh, you live and learn. CH, oh no, wait, CH1 plus plus ch2 no, and here we go. All right, and now we set another brace, close the bracket, and then we save it. Yes. Now we get out. Now we compile. Come on, Java. Okay, no mistake. So wrote it right. No, claps for me. And then we run it. Car demo main class card. Oh my goodness. Demo. CX, try, answer. There we go. X and Y equals shit. Okay, so it looks like I made a mistake. Oh no. No. Chart demo.java. Alright. Okay. What is the next line? I forgot what the next line. Oh, forward, backward, character. Previous line, next line. Okay, got it. Okay, nice. Alright. Okay. I'll save that. Okay. And I think we're good to go. Okay, so demo.java. Okay. Cut demo. Okay. That percentage sign is just the end of the line. I don't remember the regular terminal doing that, but that's cool. And here's my time tracking. All right. So we get the desired result, and now we can go ahead and read the rest. Notice that ch1 is assigned the value 88, which is the ASCII and Unicode value that corresponds to the letter X, the capital X. As mentioned, the ASCII character set occupies the first 127 values in the Unicode character set. For this reason, all the old tricks that you may have used with characters in other languages will work in Java too. All right. So page 44, part 1, Java language. Well, the chart is designed to hold, let's see if, okay, and there we go. All right, so very well. Okay, so let's make this, yeah, magnify. There we go. Although char is assigned to hold Unicode characters, it can also be used as an integer type on which you can perform arithmetic operations. For example, you can add two characters together. Okay. Let's see. Or increment the value of a character variable. consider the following program, and then it gives us a program which we are going to write. So it's car demo 2. Alright. So let's employ nano again. Nano car demo 2.java. Okay.